Do you see that on the screen now? Yeah, okay. So to talk you through a little bit, I asked first about what it means to solve an equation, right? And we talked about, well, what you do is you have an x, an input that goes into a function, right? The function is applied to it, so that might be multiplied by 2 and then add 3, and then you get an output, right? And we call that y normally when we want to graph it, okay? And often what we normally think of is I can put the same x value into two different functions and I will get two different y values out, okay, because they're different functions. So I've got, that might be 2x plus 3 and this might be x divided by 6 plus 1. And if I put the same number in, I'll get a different answer out. Does that make sense? That makes sense. Okay. So what we were saying is when we are trying to solve a system of linear equations, what we're actually looking for is the situation where if I put an x into two different functions, there may well be the case where both of them give the same value for y, all right? And we talked about this before, where what that means is if I've got straight line functions, so maybe the orange one is the first function and the green is the other, they will meet at a point potentially. And what that means is that if I put this value of x in, all right, so if I put this value of x in, if I go up to that point and I go across to find the y value, well, the x and the y value are the same for both functions, and that's why they cross. So that would be like, I put x in, I get y out. But the same with the green line, I would also get exactly the same numbers, right? If I pick a different value of x, pick a different one, I would go up and I would get a value of y for the green line. But if I pick the same value of x into the orange one, I would get a different value of y. So that would be like this situation, yeah? So when we're solving our system of linear equations, what we're talking about is where do they meet, right? And then, so if you're happy with that, we then talked about, well, how many possible solutions could there be? All right, how many could there be? And we had this discussion about, first of all, what do we mean by a linear equation? And we talked about, well, linear equations are ones that give me straight lines. Okay, so I get a straight line. And there are other ones. So non-linear, I might have an x squared, which would give me a parabola. Cubed, x cubed would give me this kind of S shape. We talked about an exponential, which is x to the a to the power of x, would give me a line that goes up. This one would be a reciprocal function because it's 1 divided by x, which is the same as x to the power of -1, and that would give me these curves with a gap in the middle, all right? And we talked about, well, how could I recognize a linear function rather than a non-linear function? And we decided that the way that we could recognize linear was that it was x to the power of 1. Whether it's in gradient intercept form, like this, or whether it's in standard form, it's got x to the power of 1. Well, the 1 won't be there, but straight lines have x to the power of 1, which is an order of 1 equation. So we said an x squared is an order 2, and that will not be straight. X cubed is an order 3, will not be straight. Okay, does that make sense at that stage? Okay, so we're only talking at the moment about linear equations and how many solutions they might have. All right, so what we then did was we looked at investigation 2 on page 326, and we started looking at how many possible solutions. And I asked people and they said, oh, well, it's always going to be one solution because I've got two lines and they cross. Yeah. And they only cross at one point because they're straight lines. Make sense? Okay. So I'm just going to change us over to Desmos. And what we did was we had a look at some of the equations. So I'm looking at investigation 2 on page 326. And I put in the pairs that they said. So I've got y equals 2x plus 1 is a straight line. Straight line is x to the power of 1, which is good. That's in gradient intercept form. But the other one is y equals negative x plus 7. Again, x to the power of 1 is another straight line. Okay. So how many solutions does that system of equations have? Like we've just seen, it's 1, because there's one point where they cross. Yeah. So what are the solutions to those equations, right, guys? What are the solutions? If I say solve those equations, what would the answer be? It's on the screen in front of you. Not just 5. You've got to be more specific. So what does the 2, 5 represent? Yeah, so which one's the x? 2, and the y is the 5. So that's the solution to those two equations, that system of equations. So I know that if I put 2 for x, I will get the same value for both of them. That value would be y, right? Is there any other value of x that I could put in and get the same value of y for these two? No, because if I pick 4, for instance, the blue line, when blue is at 4, the blue line, the y value is 3, and the red line will be at 9. So they give two different values of y. So if you think back to that diagram that I showed you with 1x going in, so 4 going in, but two different values of y happening. So the only one will be 2, because 2 will go in and 5 will come out, and that won't happen anywhere else. All right. So do you think it will ever be different? Do you think it will always be one solution? For straight lines? Yeah, always one. Okay, I'm going to switch those off. I'm going to do the next two. So I'm going to put 2y plus 8 is equal to x. So there's a straight line. Right, that's good. That's what I'm looking for. And the other one is 4y subtract 2x is equal to negative 16. Oh, what do you notice? They're the same line. So how many solutions will there be? How many places will x and y be equal? Exactly, all of them. So there are actually an infinite number of solutions for this one. All right. So these two have an infinite number of solutions, and we'll, as we get into solving them, we'll look at it. But we also talked in a sec about how do I know that they're going to have an infinite number of solutions. All right. So there is more option than just one solution. There's infinite number of solutions. All right. Then we looked at the third option on this exercise, which was got 6x is equal to 20 minus 2y, and I've got y plus 3x subtract 5 is equal to 0. Right, what do you notice about those two lines? Okay, how many solutions is that system of equations going to have? None. Okay, So we've got three situations. We've got, if they're parallel, there are no solutions. All right. If the lines are the same line, there's an infinite number of solutions. And if the lines have different gradients, so they're not parallel, we have one solution. So that's what we were looking at. So if I go back to the notes, all right, we looked at that and said, right, so infinite solutions, they're the same. We went through this, and I'll go through it again separately with you now. Or if they're parallel, they have no solutions. So how would we know? Right, that's the next thing. That's the exercise that you're doing today. But basically, to sum everything up, we just talked about solving systems of linear equations. You could have one solution if they cross, infinite solutions if they're the same line, zero solutions if they're parallel. And now it's just about looking at how can we tell. All right? Do you have any questions about that? No? Okay. So let's have a look at those equations that we were just looking at. So I've got y equals 2x plus 1 and y equals negative x plus 7. So what I'm looking for is one solution. All right. Do they have one solution, zero solutions, or infinite solutions? That's what I'm looking for. So are they crossing? Are they the same line, or are they parallel? All right. And how can I tell? Well, these two equations are written in gradient and intercept form. Exactly. All right. Gradient intercept form. And how do I know whether they're in parallel or not? No? Well, we could, all right, but we actually don't need to, because how do I know if they're parallel? They've got the same gradient. You remember talking about that? So parallel lines, we've said before, parallel lines have the same gradient, okay? Which means in y equals mx plus c, the m is the gradient. So if they've got the same m, all right, we know they're parallel. Does that make sense? So if the m is the same, we know we have parallel lines. So actually all we need to do is look at this. Because they're in gradient intercept, we just look for the gradient. And what's the gradient of this one? Nope. This one. Nope. The gradient is what the x value goes up by. It's 2. All right. So do you remember when we were talking mobile phones and things? This would be starting at 1% and going up 2% every minute or something, charging. Yeah. Okay. Now, what do we know about the second one then? Well, we know about the second one that if it was a mobile phone, it'd be up at 7% and it would be going down 1%. Yeah. So the gradients are different m values. So if the gradients are different, what do I know? They're not parallel and therefore they will cross. They are different lines. So we have one solution, which is what we agreed with on the graph. All right, makes sense? So the next, okay, well, let's do the next one then. So the next one is we've got 2y plus 8 is equal to x, and we've got 4y subtract 2x is equal to negative 16. Now, these are not in gradient intercept, but we could change them into gradient intercept if we like. So let's do that. All right, so number one, I'm going to change. So I'm going to subtract the 8 from both sides, yeah? So 2y is equal to x subtract 8, and then I'm going to divide by 2, gives me y is equal to a half of x minus 4, yeah? Okay. What about number 2? What happens when I do that? So number 2 is, let's do the same thing. So I'm going to add 2x to both sides. That gives me 4y is equal to, I'm going to write it 2x. I'm going to write it that way around if you don't mind. Are you right with that? And then I'm going to divide by 4, and I get y is equal to 2 divided by 4 is a half x, and 16 divided by 4 is 4. And what do you notice? They're the same. All right. Now, there is a quicker way of doing it, which is to say, if I looked at just different colors, so 2y plus 8 is x. And what I'm going to do is I'm just going to write it in the same, I'm not going to do gradient intercept, I'm just going to do it in the same form as this one. So number 1. Number 2, I'm going to write as 4y, and I'm going to add the 2x and then add the 16. So I'm going to have 4y plus 16 is equal to 2x. Are you okay with that? Right, and what you'll then notice is that number 2, right, this one here, is 2 lots of 2y plus 8 is equal to x. You see that? 2 lots of 2y is 4y, 2 lots of 16 is 8, 2 lots of x is 2x. All right? So we can already see that if I've got the same bit there and it's just multiplied by something, I'm going to end up with the same equation. So I've got 2 methods to do. I either look at it like that, or I convert it into gradient intercept and show that they're the same. Okay, make sense? Yeah. Okay, let's have a look at the last one then. All right, so the last one is where they are parallel. Was it parallel? It is parallel, isn't it? So we've got 6x is equal to 20 minus 2y. That's the first one. And the second one is y plus 3x minus 5 is equal to 0. So again, if we want to see if they're parallel or not, what's the best form to use? Yeah, so we're going to go back to the gradient intercept form. So number 1, I'm going to add the 2y. So I've got 6x plus 2y is 20, but then I'm going to subtract the 6x. That gives me 2y is equal to 20 minus 6x. And then I'm going to divide by the 2, gives me y is equal to 10 minus 3x. Yeah? Yeah? Number 2 then, I've got y plus 3x minus 5 is 0. Well, this one's easier. I can add the 5 and subtract the 3x, and that gives me y is equal to 5, because I've added 5 and I've subtracted 3x. So 0 plus 5 is 5, subtract 3x, and what do you notice? That the gradient is the same. How do I know they're not the same line as in the first example? Exactly. If this was a mobile phone, this would have 10% and it would be dropping. This would only be at 5% and it'd be dropping. So the lines would look like this starting at 10% and this one starting at 5%. Yeah. So they'd be dropping at the same rate, but they'd be starting from different points. Yeah. So like you said, so I know because of that value that they're not the same line. So just sort of heading back up to where we were, these, whichever one, these ones were exactly the same look, same gradient and the same intercept, whereas the ones that are just parallel are same gradient, different intercept. Okay? So that's how we can tell if equations have one solution, no solutions, or infinite number of solutions. That's what we did yesterday. All right? Any questions? No? You understand? So what I asked people to do was practice 3, question 1 on page 327 today, where you've seen those instructions. So I know you're a bit of you're obviously a lesson behind, but you'll have to catch up over the weekend then. Let's stop the call.